Hello everyone, welcome to this channel. I am Payman Hassari. In our last video, we used the elbow method to find that the optimal number of clusters for our mall customer dataset is 4. In this tutorial, I'll guide you step by step through implementing k-means clustering in RapidMiner to segment the customers into those 4 clusters and analyze it. The link to the dataset and the video are in the description. So we're going to bring the dataset into process panel, and the same as before, I'm going to choose a subset of the features that we have using select attribute operator. Bring the operator into the process panel, connect these two operators together, and configure this one. Include attribute filter type is gonna be a subset, and the subset of features that we're going to choose is age, annual income, and spending score. Apply. The next step that I'm going to take in order to apply k-means is to normalize the dataset using normalize operator. Bring the normalize operator here, connect these two operators together, and configure this one. And here, attribute filter type, I'm going to normalize all the features. And for the method, again, there are different methods that I can normalize the dataset. Again, I use Z transformation. The next step is to build k-means clustering model. In order to do that, I use an operator called k-means. Bring the k-means operator into the process panel, connect it to the normalize operator, and configure this one. Here, the value for k is 4. That is the optimal value that we chose from the previous video. And max run by default is 10, which means that RapidMiner will run k-means clustering 10 times with 10 different initialization and choose the best out of that 10. And we'll leave the rest as their default values. Next, I'm going to calculate the performance of the model using cluster distance performance operator. Bring the cluster distance performance operator here. Connect these two operators together. And configure performance operator. Main criterion, I'm going to choose average within centroid distance. And I'm going to normalize and maximize it. Let's take a look at the results. Connect the performance to the output, as well as the data. If I run it, this is the performance, which we see that average within centroid distance is 0.34. And now we see that for each row in the data, there is a cluster that is being assigned into that row or in that data point. Next, I'm going to analyze the data in each cluster. But as you see, the data for each feature that we have is normalized. In order to have a right analysis, I need to have the original data set. And in order to do that, I need to denormalize the data. And in order to do that, I use denormalization operator. Bring the denormalize operator here. Connect it to the normalize operator. This operator inverse whatever normalization this normalize operator has done on the data set. And I need to apply this model on the normalized data. I need to bring the apply operator. Bring the apply model operator here. Model should be connected to the model, and the data should come from the performance. And if I take a look at the result now, we see that I have the original data now. And I can take a look at the analysis that I want to do. Let's go to the visualization. And as you see, the box plot is the plot type. And on the value column, we can choose any of those features that we have and group by cluster. For example, in terms of age, cluster 0 has the lowest average or the youngest customers, and cluster 2 are the oldest one. And if we change this value to, let's say, annual income, then we see that cluster 0 has the lowest annual income, while cluster 1 has the highest annual income. And if we want to quantify this, I can use an operator called aggregate. Bring the aggregate operator here. Connect it with apply model and configure this one. I'm going to use default aggregation, and the attribute filter type is all because all of them are numeric. And group by attribute, I'm going to choose cluster. Apply. And leave the rest as it is. Connect it to the output. And run the process again. And this is the average value of age, annual income, and spending a score for each cluster. For example, cluster 0 are the youngest customer, while cluster 2 are the oldest one.